So the title of this section would be, this is section 6.3, Integral Calculus and Total Accumulation. This is a huge idea for you guys. See, if all that the integral did was just give you area under curves, then why would we care? But it turns out it also helps me to add, helps me to total things up. And that really is kind of the big application for this whole going backwards, this integration. It really means more, and I think by the end of this lesson, you get a better picture for what it really means. But I'd like to start with the geometry because that's something you could see. But I'm hoping that by the end of this, you guys will see, oh yeah, I kind of get that. But I want to bring up, there's a key idea here, okay? So the key idea is this. Suppose f is, let me spell this correctly, continuous on the closed interval AB. Okay. By the way, this is actually a nice little aside. If I say that f is continuous, does that mean it's differentiable or not necessarily? Not necessarily, right? We saw that. We had the absolute value example. It's continuous, but it's not differentiable. Ben, question? Oh, okay. But here's the other thing. If I tell you guys that f is continuous, it is, and here's the word, integrable. That means you are able to do the antiderivative. You are able to integrate, okay? So suppose f is continuous on the closed interval AB. Okay? Then, when I do the integral from a to b of f of x dx, and again, how do you do it? Well, you take an antiderivative and then do big F of b minus big F of a, right? So this is what we just learned how to do. But what's it give me? It gives me the total accumulation of the function f of x on the closed interval AB. The total accumulation. How much of f we accumulate. And you have to see some examples for this to make sense. So I picked out a few problems that I think do a pretty nice job of this. So on page 454, number 18 is where I want to start. Okay. Problem 18. And I'm going to go ahead and put the book up here so you can see what's going on. This one is very personal for me at age 42 and a half because I'm deciding, yes, I got to get the reading glasses, guys. It's going to happen. I'm feeling my age right here. I've always had great eyes. I mean, they've been great to me. But it was funny. We were at a birthday party or something, and my sister's like, Paul, can you read that beer bottle? And I'm like, and then she handed me her reading glasses. She's like, it's time, it's time for me to do it. So anyways, here we are. We have See the Fine Print Company, right? And what is it that they gave me? MP stands for marginal profit, okay? So this, we can graph the marginal profit. It says from 0 to 60. X is the number of reading glasses sold, MP is the marginal profit in dollars. Okay? Determine the resulting increase in profit by changing the production and sales of the reading glasses from 30 to 40. Here's the question. Is it worth it to change our production level? You know, what will that do if I can do it? All right, well, let's see. I want to sketch a graph, so I may as well use the software. It'd be easier. I know it's a parabola opening upward, but let's go ahead and use the technology here. So I have 0.0015, right? Let me do this in the y equals screen. 0.0015 x squared minus 0.01x. Okay. If I press graph now, I don't see anything. I bet I have to go ahead and get myself a good window. Well, one thing is x min and x max, that's given to me. So I'll go from 0 to 60, and I'll scale it by 10. Now, I may not have any idea what to use for my marginal profit yet, so I'm going to press graph. Oh, I can see it now, right? It's a parabola opening upward. Okay. It gets really thin down here. It says determine the resulting increase in profit by changing the production and sales of the reading glasses from 30 to 40 units. Let me do this. If I hit second, calculate a value, 30. 1.05. 1.05 is the what? Let's interpret what's going on here. I got a number, 1.05. Yeah, it's the marginal profit, right? So when you say that, if my production level is 30, I'm selling 30 glasses a month, right? And instead I increase it to 31, I'll be upping the profit by $1.05, approximately. Now, let's try 40. So let's calculate a value at 40. Now my marginal profit is higher, right? Now it's all the way up to 2. So if you can increase past 40, the profit increases even faster. Right? So a lot of times in business, we may know the margins. We may not have a profit function like we did in the first half of the class, but we may know the margins from our analysis of what's happened, okay? And so let's talk about what happens here. It says determine the resulting increase in profit. All right, so it tells me that C-defined print, we have the marginal profit, which is P prime of X, is given by 0.0015 x squared minus 0.01x. Okay? So there's the marginal profit. And I'd like to compute what's going to be my increase in profit if I go from 30 to 40. What I'm telling you is that the key idea tells you, oh, you can get that. You can get the total accumulation of that profit increase. How? We're going to integrate here from 30 to 40 the marginal profit. This doesn't look too hard. So I can do this. by hand with an antiderivative. So it's going to become an x cubed, and that means I need to divide by 3 out front, and so that's going to become 15 divided by 3 is 5, so it's 0.0005 x cubed, right? Minus, this is going to become an x squared, so I need to divide by 2 up front. So instead of 0.01, are you guys okay with me writing 0.005, right? Because 5 times 2 is 10, there'd be a 0 there. Is this okay? So I just did the antiderivative, and over here I draw my line, and I have 30 and 40. Okay. And what you can say this is, right, this is kind of the extra profit that I'm going to make by increasing my production level from 30 to 40. You're definitely going to make more profit. The marginals are positive. Ben? Question or? Okay. So, kind of go through here now and just figure this out. So we have we'll plug in the 40 and the 30. So 0.005 times 40 cubed minus 0.005 40 squared minus, and I'm going to put this in brackets, 0.0005 30 cubed minus 0.005 30 squared. So this is 64,000 when you cube 40. And this is 1,600 when I square 40. And this is 27,000. And this is 900 when you square 30. So let's see. At this point, it's time to use a calculator. Go to the home screen. 0.0005 times 40 cubed. I mean, I guess I could have gone to the home screen last line, right? It makes sense. Just to double check everything. Minus 0.005 times 40 squared. And then what you might do, if I'm using the previous line, is you might put these big parentheses right here. So minus, open parentheses, 0.0005 times 30 times 30 cubed, and then minus 0.005 times 30 squared. Close parentheses, and if I did that all right, I got 15. What a nice number. You know, I also had this thing in the graphing calculator, so I can double check it, my work here. If I go to the graphing calculator and use choice 7, we can integrate again from 30 to 40 and see if I get 15, and then I'll say yeah. Okay, so I'm happy with my answer, right? So what's it mean? What's this mean for the business?
increase from 30 to 40 units, you're increasing your profit, your marginal profit by the difference.
Not the marginal profit,
The profit.
the profit. It's we will accumulate an extra 15 bucks. So then you have to ask yourself, is it worth an increase in production?
Another 50 years ago.
Well, I guess what would it take for me to increase my production level? Do I need to hire someone else? Do I need to pay overtime? Do I need, right? I don't know. So, but that's, yeah, $15 extra profit when production is increased. Okay. So moving ahead, I like number 28 also. I like number 28, so that's the next place I'm going to go. We're going to talk about velocity here. What's velocity mean? It's like speed. Yeah. You talk about it, say, in a science class, or the velocity is both speed, but you also have to know the direction that something is going also, right? So if I just tell you my speed, you don't know where I'm headed. But velocity also implies a direction. So anyways, problem 28 is a velocity problem. And what we are told is that the velocity of an object is given by v of t is equal to negative 32t plus 120 when t is greater than or equal to 0. Okay. Part A says just evaluate v of 1 and interpret. So I'm going to go ahead and do that, although I'd like you guys to help me interpret it. So let's see, 120 minus 32, I'm getting 88. Well, in order to interpret it, it really helps if I know what the variables represent, right? So what is t? They told me t is time measured how? Seconds. And v of t is velocity measured how? Feet per second. So then how would I interpret this? I would say, well,
Every second it travels, you're decreasing it by
32 what? 32 feet per second. Yeah. Have you guys ever heard that before? 32 feet per second? Well, it's interesting. You may have a number in mind that you have associated with the force of gravity. If I say to you guys force of gravity, does any number come out at you? No. If I ask Math 2500 students, they're going to all shout out 9.8, because they learned in their science classes that the force of gravity was 9.8 meters per second squared, or per second. Now, I didn't learn that growing up. My dad was an engineer. He taught me, oh, the force of gravity, 32 feet per second. In other words, I'll tell you where this problem comes from. When you said every second we're losing 32 feet per second. That's because what we just did is we threw something up in the air and it's slowing down. That's what's happening here. I guarantee that. Matter of fact, I could tell you that. So this says 88. What this means is, think of this as a little rocket that was launched. 1 second after launch, let's say. Now, it didn't say that anything was launched, but I'll tell you that's what happened, because I can see from the equation. 1 second after the launch, okay, the object moves with a velocity of 88 feet per second. Okay? So that's why you interpret part A. All right, part B. Determine the total displacement of the object in the first 2 seconds. Displacement. In the first 2 seconds. Yours says 3?
Yeah.
So does mine. I was looking at 27 there. Thank you. First 3 seconds. All right, I want a graph again. I just think that a graph really helps. So let's see what's going on here. Y equals, clear this thing out. Let's put in negative 32 plus 120. Negative 32t, so I want negative 32, I don't have a t button, I'll just put an x there. Okay. Let's try the standard zoom for starters. I don't really like my picture. I mean, it's okay. But of course, we know that if I were to hit trace, see when x is 0, y is 120, right? That's because v of 0 is 120. V of 1 is 88, right? So let me do this. Let me change my window. And for my x's, I'm going to start at 0 and go to 10. That looks good. And for my y's, I'm going to start at 0. I don't know. Keep it at negative 10. But I want to at least get up to 120. So let's go up to 120. And I'll put a mark every 10. Okay, let me graph that. Yeah, that's my velocity. My velocity started at 120 feet per second. But my velocity, so I launched it upward at 120 feet per second, and it's slowing down, it's slowing down, it's slowing down as the rocket takes off. Because gravity's fighting it. Okay? So question is, how high does it get in 3 seconds? See, this is feet per second, but we can tell you how many feet in the air it's going to go. How? Well, do you know? My displacement will be integral from 0 to 3 v of t dt. That's all I have to do. Why is that? Well, let's compute it first of all, and then we'll talk about why it is. So, hey, here we go. Got my calculator. Choice 7, lower limit 0, upper limit 3. Somehow we will accumulate 216 what? Feet. This is 216 feet. The thing will go 216 feet in the air in 3 seconds. That might be hard to believe. Well, let's see. It was going 120 feet per second. Then it was going 88 feet per second. Then it was going, what's v of 2? I may as well compute it. Well, actually, I have a little chart. I don't need to compute it. Look, guys. Like you said, I add it all up. I'm going to hit second table here. Ah, there it is. V of 0 is 120. V of 1 is 88. v of 2 is 56, and v of 3 is 24. Now, if you add that, don't you get more than 216? You do, don't you?
All right.
So it's not quite adding those four. Well, you know why? If you just add these four numbers, that's kind of like computing the integral with four rectangles. Remember how there was error? That doesn't work. Or if you skip the first one and use the next four, that's like calculating the integral with the four right endpoints, and that'd be an underestimate. But yes, it really is the exact value of how many feet you're going to move. Now, it's still a little bit magical, and that's because we did it on the calculator instead of by hand. Do it by hand, you're going to learn something, I think. All right, so what are we going to do? We're going to integrate v of t, which is, well, negative 32t plus 120. dt. 0, 3. Okay. And so what do we get? We get, what do you get here? You get t squared, and what goes out front? Negative 16, good. Plus, this would be 120t. Right? Negative 16t squared plus 120t. And that's from 0 to 3. And then etc. And eventually you get that 216. You guys know what to do from there. But, okay, I'll work it out. Negative 16 times 3 squared plus 120 times 3 minus 0 plus 0. You guys see that? You plug in 0, it works out really nice. So let's see, 9 times 16 is negative 144 plus 360, and like I said, that gives me 216. Okay. But I think what I really want to focus on here is this right here. Negative 16t squared plus 120t. What shape is that? A parabola opening up or down? Which way? How do you know? Negative 16t squared, right? Let's actually graph it on the calculator. I'm going to graph it right below the function I have here. So I'm going to graph negative 16x squared. Then I'm going to say, what is it? Plus 120x. And this function is actually going to show you the position of the rocket. Let me graph that. No. Well, you can't quite see it. Why can't we see it? Well, a couple reasons. One is if I hit trace, I'm at negative 40 when I'm at 5. Why would that be? Oh. Well, that's interesting. Okay. Here, let's do this. We're going to change our window. So let's change the window. And instead of going from 0 to 10, let me go from 0 to 5. And also, I don't want my y max to be 120 anymore, because we know this thing goes 216 feet in the air. Let's make it 300 for y max. And I'll put a mark every 100. And so, let me graph. Now that line represents velocity. But this curve is the actual rocket. So it takes off, and it's still getting higher and higher until it reaches its maximum point. And Then actually, what happens next? Why is it coming down now? Yeah, and actually notice what happens. That happens right when the velocity becomes negative. You see that? So your velocity was pretty big, and as it slowed down, this thing, instead of going straight, starts curving. Do you see it? How much distance does it actually get in 3 seconds? Well, we integrated and we got up there, it was 216. 216. So I think that's kind of nice to be able to see. So I'm going to finish this little lesson with this example from problem 38. So it says, Georgia is growing. But what's this graph show here? It says the rate of change of population. So it's growing, but it's not growing as quickly as it used to be. I still remember when I graduated college, 1994, I had a good friend move to Atlanta. Then they had the Olympics, right? Atlanta had the Olympics in the 90s. And then, I mean, it was just growing. It's still growing, but not growing as fast as it used to be, right? Used to be growing, well, what's this? At 0.14 million per year. Now it's growing, let's see, 2015, we're right here at the start of this graph, maybe 0.13 million per year. That's still a lot of people, right? 14,000, 13,000 per year. And then what they're doing here is they're noticing that rate of growth, and then they're projecting what's going to happen towards 2030. Okay, so this is, you know, an estimate from the U.S. Census Bureau. So it says here, knowing that the rate function is this, compute the shaded area and interpret. Now, how do they know that's the rate function? Do you guys have any thoughts about that? This is not a guess. I'll tell you how they know. Look, we probably have the data point for 2000, 2005, 2010, and even maybe this year, right? We have those 4 data points. Draw a line. Do you guys know how to find the equation of a line? Sure, what do you need? You only need 2 points, right? So you pick 2 good points. If they're not quite lined up, you do something called best fit line, which we could do that in stats course with you guys. But look what the y-intercept is, 0.14. That sure seems to be about right. And I'll tell you that if you worked out the slope. So we have a pretty good idea from a trend-wise of what, if it's a line, what the rate function is. So now it says, okay, let's compute the shaded area and interpret. So I'm going to pause and let you guys do that, and then we'll see what you guys come up with, see what you've learned from this lesson. All right, I'm going to try and catch up to you guys. I'm going to integrate this thing. Integral of negative 0.001 x plus 0.14 from when to when? So it's from 15 to 20, right? That's what we want, because we want the area that was in the book. So I'll just integrate from 15 to 20. Okay, I get, well, this becomes an x squared, and this becomes negative 0.00. Instead of 1, I'll put 0.5 plus 0.14x, and that's from 15 to 20. Negative 0.0005 times 20 squared plus 0.14 times 20 minus negative 0.0005 times 15 squared plus 0.14 times 15 I'm going to go ahead and use a calculator for this. Let's see what I get. And then I'll try and interpret. And by the way, if you're trying to interpret, if you guys are ahead of me, a couple things you want to do. Tell me what x represents and tell me what p of x represents. That's going to help. Okay? So I'll pause for a minute. All right, I'm starting to compute it. Negative 0.005 times 20 squared plus 0.14 times 20 minus, open parentheses, negative 0.000, oops, I don't want that 3 there. 0.0005 times 15 squared plus 0.14 times 15. Close parentheses, and that should be it. 0.3875. Anyone else get that? No? Did I make a mistake?
It should be negative 0.005.
I missed the negative. I put a 3 instead of a negative, and then I didn't correct it. All right, so let's bring that all back. Second entry. Steve, I'm glad you caught that. Right here, where I had that 3, I meant to put a negative, and I must have just been, I see. I just typed above it. So there it is. Enter 0.6125. Did you guys get that? Well, now we're close. Where's my typo? 20 squared plus 0.14 times 20 minus, put that in, times 15 squared plus 0.14 times 15.
That's what I got.
You got this?
Yeah.
That's what okay, so 3 of us got this, 0.6125. You know, it's funny. I really think that an easier way to do these problems is to not even do it on paper. You know? What I'm saying is this. Let's go to the y equals. What should I type in here? The negative 0.001x, right? Let's actually graph the same picture that they have in the book. I want to get that in my calculator. Plus 0.14. Now, what kind of window do we want? Let's look in the book. It looks like it goes from 0 to 30 for x. What does x represent, by the way?
Years is 2005.
Well, let me write that down. Remember I said that's important to write. So years since 2000. And what does p of x represent? They write it there.
Change in millions.
Rate of growth or change in population, and this is in millions. Okay. So, what am I going to do here? Oh yeah, for the y values, well, it looks to me like the picture goes from 0 to 0.15, and they put a mark every 0.05. Right? So now I have the same picture they have in the book. There it is. And now I can do second, calculate. Choice 7 is definite integral. Lower limit, yeah, 15. That's what I want. Upper limit, I want 20. Integrating from 15 to 20. There. Less likely to make mistakes that way. 0.6125. Okay, so it's what we got here. Now we have to interpret what it means. So what does it mean? What are the units that we want? Well, you have to know what the original function was. The original function we integrated was p of x, right? P of X, the units of that are millions, right? So this is the total what? Population increase yes, and again, it's in millions. So if I had to interpret, how would I interpret? I would say we project over the next 5 years the population will increase how much? Well, since these are millions, why don't I say 612,500 people. Does that make sense to people? That's really cool that the area means something. It means if you have a rate function and you find the area underneath, you're actually talking about how much is going to accumulate. You know, this same picture, I could tell you, hey, let's go back and let's compute how many people there have been added to Georgia over the last 15 years, right? So I could just do second calculate, the integral from 0 to 15. Boom. 1.98 million. So over the last 15 years, there have been almost 2 million people added to the state of Georgia, according to the U.S. Census Bureau. That's pretty cool.